cast off. That's this guy recording live from Twitch TV. And we're in the saddle again. Working on the things. Gonna build all the things today. So, yesterday we found a bug with the tests, technically the tests. Like I keep saying, tests are code that are not tested, and so we found an issue with how the mock was returning the data. It was actually returning an image asset, which was wrong. It would actually supposed to turn the actual data from the asset loader. So I patched up the test, patched up the code, dried it up as best I could. It looks much cleaner now, so we're just going to run the tests again, and we should have passing tests. Be better because I just fixed them. Okay, so there they are. Oh, yeah, all passed here, so let's do it. So what we're going to do is going to go back to here and run our game. I think it'll crash. I forgot where we left off, so it's likely it'll crash. So we'll see here. Gonna build her up, bring her down. And survey says, sending the code, and crashed. Okay, so construction args, create instance. So what we need to do is we need to update our injection mapping. And we have another set of things like this. So we're going to do this. And this is for our asset stuff, our asset things. So whenever we get a text asset, we're going to return a ca text asset. Whenever we get a image asset, we're going to give back a ca image asset. And whenever we get a ca sound asset, we return sound asset. Return a ca sound asset. Yep. Test will definitely pass it as an effect test, but they're running anyways. Can't ever run the test enough. In fact, kind of a fan of just running tests. Just it feels good to be all passed and green, and I don't know. Maybe I'm just weird that I like passing tests all the time, but that's just me. I just like when code works. So we have our game up, and we have this crashing, which I think, let's see here. Let's go to live game. So let's look here. We have cost sound asset. So we should be able to do our sound asset data. Let's trace it just to see what it is. I believe we can hit play on it. And so I'm going to pause our music and see if this will happen. We should have music playing. And survey says, waiting. No function pointer. So it is a sound. Let's make sure here. Alright. Back. Up here. Okay. Alright, so we get a sound. Sound. And let's look at, I think we have this in our history of here. Let's just look back just want to make sure what we were dealing with before. Load sound. And so we actually used the audio play. And that's where we went wrong. Or I went wrong anyways. So let's do this. We're going to go to here. Audio, sound, play, true, and run our tests just because it's a habit. And non-identifier sound. Sound asset data. And that should do it. Alright. Getting too excited here. Alright. Should have a sound. Should have a sound. This is what we're going for. There we go. We have music. And we have a crash, which we don't know. I don't know why yet. So we're going to do on update here. So I'm going to get our music playing again. So on update, we're getting some our audio channel here. That is not being initialized. I think if we do our audio play somewhere in here, audio channel equals that might be the trick. And we'll have our sound playing again, which we'll eventually take out and abstract out anyways, and we can control it in a better way in some sort of sound controller. But sound still works. It's just, this is just the game building process. Layers build on top of layers, build on top of layers, build on top of layers, and finally you get such a high level layer, you hit play and the game works. So there we go, there's our buddy running around, looking good. Let's go, buddy. There we go. So that's abstracted out. So now let's get our wizard, our necro display back in gear. So we have a couple of interesting things going on here. Is we have our idle, we got our images, we've got our frames, and I kind of want to get rid of this underscore, I'll get rid of this JSON, and that's going to just be abstracted straight into our asset loader. Same with this. So first of all, let's get our images loaded, idle and run. So now we're just going to inject our AssetLocator. Okay, and we're just going to use here AssetLocator, get asset by name, and this asset by name gives us an image asset. So what we'll need to do is we give it the necro idle. I'm going to extract this out just for the time being, and this will give us our idle frames, idle asset, image asset. So they give us that, so we should be able to give it the idle asset data. And so we'll see how that works. We'll trace our idle asset and our idle asset data and make sure we've got all the stuff we need. And once that is in place, we can use it more effectively, and then eventually we'll write tests around this and make it less kind of playgroundy and a bit more real game ready, solid as a rock. So this could crash. We'll see. Nope, he's there. So that worked out perfect. So what we're going to do, we're just going to grab this and drop that here. And I've never actually done that, so let's see if that actually builds and runs. Yeah, see, it's weird about that. So we're just going to rename this to asset, and we're just going to rename this to asset, and this is going to be see here, we're going to do necro run, and there's our asset data there. Wonder, let me just build that real quick. I think I did this weird just now. I think I can actually do this. No, that wouldn't make sense. We'd have to do like this. We could do this. I think we can do this. We want to one-line it. And our game here is taking a long time to load. So let's figure this out here. Let's undo this. And do this too. Let's find out what's going on here. Alright, so that's looking good. We've got our run, image necro run. So we trace asset. Oops. I believe if we, I don't know why this was asset data. So that appears to be okay. It gives us a call image asset. So maybe it was just a weird fluky thing. Sometimes that happens. And once this is in place, we're looking really good. We just need to abstract out this JSON bit, which maybe we'll keep it, maybe we won't. I don't know. It's hard to. It is an actual resource. Okay, it was just a weird fluky thing. Okay, there we go. There's our guys running. So now we're using our asset locator. This one here we're using create frames. And here key string pose index key. So I'm definitely going to take this off. And we're going to drop this here. That definitely makes that a little bit clearer. And we want to asset locator load get data asset by name. This gives us a string. And so that should do it. There we go. I really don't like the idea of having the JSON on the end, the extension. There's really no other way of knowing it. So, might be just one of the things I'm gonna have to just live with. And there's our game, frames all run again. And now we're actually using our asset locator. So I'm happy about that, because now we've abstracted out our asset locator, and we can control the assets in a lot more meaningful way. Let's go to our wizard display. Let's finish him off. I know we don't use him anymore, but AssetLocator, AssetLocator, and then this is the AssetLocator, get asset by name, and then here this is going to be image.data. Image here is going to be image asset. We give that the image data here, asset locator, get data asset by name. There we go. So that's cleared up. And now clear that out. Look at that, much cleaner. So get status, git commit, integrated the asset locator and asset loader into the playground. Boom. Git push origin master. Get that up there. So now we're going to tag this too, just because we did a lot today. Git tag. Oh, how did we have to tag? Let's see how we can do this. Git tag. Okay, so it's just that. Okay, so date git tag 2016 0426 0807 git push. So we have this checkpoint here for today. So what I wanted to get into, we may not do much more coding, is just going to set up some of our interfaces. So our game's in a pretty good spot, and I want to really get into networking. It's going to be the next big piece of what we're going to be doing. And I'm actually not going to use hacks for the backend. I've used it in the past, and it's great. I'm not going to say any bad things about it. Usually I've done it where I compile the JavaScript to Node, and I can reuse the front end and back end. But this time I'm going to do something different. What I'm going to do is I'm going to use a language called Elixir. And Elixir is a functional programming language. I've fallen in love with it. We're on a honeymoon right now. I've been coding on it in almost a year and a half. It's really cool technology. It actually runs on top of the Erlang VM. And what's great about that is that we get multiprocessing for free. We get that's really easy to work with. We get distributed computing that's really easy to work with. We get some good frameworks to work with. It's a really neat, clever language. It's all functional, so we're going to get away from our OOP stuff. We're going to get into functional programming. And this is pretty slick technology. I'm really excited to use it for this. I've been kind of thinking about it. So what we're going to do is we're going to actually create a new directory. And so what you do, how to install Elixir, is if you're on a Mac, you can, there's instructions on the Elixir website. If you're running Windows, you can get precompiled packages and use the installer. For Mac, for Mac it's pretty easy. You can just use Brew, which we'll be using. If you're using ports, all the instructions are here. The tool set is really nice. There's if you're running any sort of Linux flavor. It's really easy to get into. I've got it running on my Raspberry Pi. I've actually got it running on my phone. It's really well done. So for Mac, you just do brew install Elixir, and it'll install the latest. Actually, I should probably do brew update. So I brew update, that'll get all the latest definitions. I believe I'm running the latest Elixir anyways, but this is a bit of a formality. And this is going to handle our networking and our whole back-end system of our game. And we can scale this really, really nicely with Elixir / Erlang and make it very distributed. We can have multiple servers. All the servers can talk to each other, and it's going to be really easy to set up. And so let's get this going. So I'll let you guys know as we follow along. We're going to be using, two particular languages in this, and there's nothing stopping us from using HAX and Node. I actually very much recommend it. Just especially if you're starting out, it's a lot easier to get more done faster because you could just reuse a lot of your code. So yeah, I have Elixir is installed. Actually, I think I want to do brew upgrade Elixir because I think it should be on 1.2.4. There we go. So this I'm doing is because I'm just looking at a larger scale game. I want to support as many players as possible, and so this is just a much, in my opinion, better technology for that than trying to use Node and JavaScript. Node and JavaScript could possibly be faster than Erlang. Erlang does compile down to a bytecode, so it does run pretty fast, but it is functional, so you get all the functional things out of it. But with Node, we're constrained to a single thread on a single CPU core. With this, we can use all the cores that we need. So if we just need to scale up, we don't. It just does it automatically. Whereas Node, we have to create new Node instances and manage all the different Node instances and have them talking to each other, which can get really, really complicated and hard to maintain. If you're building a smaller game, but there's a small server side, I'm not talking you out of Node. I don't want to talk you out of Node. Node's super fast. And like I said, it works really well with HAX, and you can actually run faster HAX code than you could with regular JavaScript just because of inlining. So there's a lot of big gains to using HAX and Node, but I'm going to use Elixir for this project just because I like it and I think it's going to scale very well. So what I'm going to do is I'm going to create a new project, so it's mixed new, and we're just going to call this live game. How did I do this before? Live game backend. And actually, the style is like this: snake case, live game backend, and actually creates our files to be set up. So easy, we can just run our test right away. We have one passing test, so we're set up. And just to make sure, as with every programming language, we want to run our hello world. So in Elixir, we have IEX, which is interactive Elixir, and that goes into a terminal, and we can just run commands right in here. We do IO puts, hello world, make sure we use double quotes, and those are hello world, and this little OK here means it executed OK. And you're going to see sort of the same similar pattern that we used in our asset loading that Elixir uses. I learned from Erlang on how to pass messages better, and I've grown as a developer because of it. So we're looking good here. So what we can do, right now I'm going to kind of just play around a little bit and sort of understand how the Elixir, and just sort of show how Elixir networking works. We should be able to network TCP-wise between two Elixir points. We can also do distributed Elixir, but I'm just playing with the socket so that we can talk to our game over the socket. So if you know anything about Elixir or Erlang, you're gonna be like, why are you doing it this way? It's because I'm setting myself up to talk to our game. So what we're gonna do is we're gonna look at Gen TCP, and there's also a Elixir socket library from Meh. And I've used this one in the past, and it seems kind of nice. Talking to the raw Gen TCP, which is the Erlang implementation, is also very involved and has lots of goodies. But I believe even with using socket, I think we can get actually down to the Gen TCP if we need to. And so what we're going to do is we're going to just set up two connections here. So I'm going to just break this off. Oop. And then set one up here. Hopefully you can see that. So we're just going to put these side by side, like so. And make this one slightly bigger. There we go. Resize it. So here we should be able to IEX on each side. IEX. So this side's going to be our server side. Okay. Oops. You know what? I'm going to shut this down back here just because it's in our way. And this is going to be our client. So we know that the difference between the two. So what I'm going to do, I'm actually going to go with using the meh socket. And so I need to actually go to the live game backend. And we're going to look at our mix file. This is kind of like our ca file. This is where kind of our libraries are set up. So our dependencies, if you will. So what we're going to do is we're going to just use this as one of our dependencies. So it's at version 3.2. So we're going to use, I think it's just Elixir socket, and put this in a tuple, and this is going to be greater than or greater than, yeah, passive greater than, and what was the version? 0.3.2. 0.3.2. And I'm just using VI here. So we should be able to mix deps.get, and that should get our dependencies, and it's not Elixir socket, but we need to mix local hex to get our latest package manager. This is just like Haxlib, but for Elixir. And I need to figure out what's their application name. I think it looks like it's just called socket. So I'll just use socket. So mix deps.get. There we go. It's got our socket, and we're ready to go. So now if we just run IEX, I just run the interpreter alone without our libraries. What we need to do is we need to run IEX -s mix. So that actually runs through mix. So we get our socket stuff with it. See how it compiled it in right here? So that means we have everything listed in our mix file ready to go. So we're going to clear this out so we can get nice clear. And let's take a look here. So we've got a nice example here. So let's just set up this one here, this server. This is our server end. And we're just going to pretty much copy it straight out. Server equals socket.web listen, and we're going to do 4000, and then client. Client equals server socket web accept. So that's going to wait for us. And now we need to create a socket on this side. And so I think, let's see here, this is what we need here. So we're going to do here, let's see if we can see this okay. Move this over, just get our space working. Okay, so we have sock equals socket.tcp.connect, and the host is going to be localhost, and the port is going to be 4000 because that's what we chose. And so we now have a port, I think. So this is still waiting. Yeah, I think that's not what we want. Let's try this again. So server I think we want to use socket TCP listen on 4000. And then client equals server pipe operator. So what this pipe operator is, this is really clever, is it's kind of like pipe in bash. And so if you need to, like, this is similar to just doing socket, oops, let's type correctly, socket TCP accept, and we pass the server as an argument. So that's exactly the same thing as this. It basically uses it as its first argument. You can chain these together. And we'll use this more as we get into it, but I'm just going to show you this other way, just to show you it does the exact same thing. It's just some syntactic sugar. So there, that's waiting for the server. See if this will, there we go. So now actually connected between the two. So we both have a client port we can talk to, and we have a socket port. So now we should be able to send some data to that socket. So it's a sock, we're going to do the pipe operator, which I'm going to skip for now. So we're going to say socket stream send, and we're going to send some data to the socket. Let's do hello world, as we always do. Hello world. So that'll actually send. It's actually received on this end. It's just waiting in a mailbox. And now we just need to pick it up. And so what we need to do is we need to sort into a variable. We'll call it data, and socket.tcp.receive, and we're going to pass our client. And if we did everything right, it should work. So it's not so socket stream. There we go. There's our data. So now we've passed data back to the server. Now let's send data back to the client. So what we're going to do is we're going to say socket stream send. We got your data. Thank you. And so we're going to send that back, and we got to make sure we pass our client sockets back to it. So I'll send it, and here we should be able to receive it. So this is our response. So socket stream receive from our socket. There we go, and we have our response. So now we're talking socket to socket. We know this is going to work, and it's a pretty nice little interface. So just for fun, let's just send some numbers to it. So it says it's unhappy about sending numbers. And that is not what we want, is it? So let's see here. Are we going to send data? I bet you it's under lib socket TCP stream. So we have a send, and it's looking for string as a file, IO data. So what's interesting is strings are just data. Strings are just data, but what we need to do is we actually need to convert this number to a binary. I believe it's Erlang term to binary. There we go. And if you receive the data, there's our data. And so we say, we just use the data again, and I'm going to use Erlang binary to term. And that's not the right one. Oh, probably because I need to pass the data to it. And there we go, there's our number. So now we're passing numbers back and forth, which is super important to what we need. And it wasn't that complicated. We were able to use it in the terminals, and I feel like we're looking pretty good here. So I'm going to leave it at that. We're going to set up our socket tomorrow, what we can do is we can pre-set up our game side. So I built this library some time ago. This is me, called Neutrino. And this is where I built a lot of my games years ago in hacks when I was just kind of throwing it together really quick. Everything's underdeveloped. And you feel free to use all this. It's open source. So I have some common stuff. A lot of it's not real tested. This is what I'm kind of going through with hacks. This mostly works with, if you go to, so we got some common stuff, we got some C++ stuff. Flash actually works with OpenFL. You got some container stuff you can play with. I don't really use much of it anymore because there's other libraries that are more maintained and updated. There's some similar things. There's a translation manager. You can use all this stuff. I'm just kind of going away from it and using more of this newer cost stuff, just my own learning. This is one of my favorite tools ever if you ever want to use something great with vector graphics. And so feel free to use it. There's also a JavaScript one for JavaScript specific stuff. More specifically, you would probably want to play with the node socket and the node socket server. This is where I do similar to what we're working on, but with Node. It's not fully finished. Like you can see some of these just return null as UTF or read short as 0. If you ever want me to patch it, I'd be gladly to for node socket, and there's a node socket server if you want to set up a node socket server. So kind of what I was saying earlier with the, you can use some Mongo database with it. If you want to use JavaScript for your backend, all power to you. You can use this library. But what I'm going to do is I'm actually going to go here to net somewhere. Maybe under data. Oh, that's chat. Looking for a particular interface. IO probably. Yeah. So I have this input-output stream that I use. And so this abstracts out the socket layer, which we'll be doing. So we have our input stream, which is all this stuff, and then we have our output stream, which are these things. So we're just going to use these. So what I'm going to do is I'm actually just going to take this input stream, I'm just going to rip this straight out of here, and I'm just going to make my own package here, which is IO, and create a new hacks class, and this is going to be input stream. It's going to be interface, and there we are. We don't need an object encoding, so we're not using that. And then we're going to need an output stream. So this is going to be our way of just abstracting out our interfaces that are specific to our target platform. There we go. And then we have our input-output stream here, which uses both. So hacks class input output stream. Oops, no. Interface. So here we're going to just add these guys, and then we're going to extend input stream and extends output stream. So we're set for our input-output stream. So we can test against it, and we can build against it, etc. And it's nice and abstract. We don't know about the socket layer underneath. So let's get back here. Here is our source.io status git commit added input output stream interfaces. There we go. There we go. We're going to push this to master, date, and we're going to tag it. Not much going on with this tag. Probably going to keep it the way it is. So now, tomorrow, we're going to start talking our back end to our front end through Elixir. So I hope this was an interesting, informative day. We've got some integration in, and we're getting ready to integrate our networking. This is probably going to take a week, so it'll be fun. All right, you guys have a great afternoon. I hope to see you tomorrow.